Hi everyone, today is February 22nd, 2019. This is my 11th episode about C++ type function, modern C++ programming. In this session, I will talk about understand modern C++ language correctly, trust your compiler, and relieve yourself from unnecessary burden. We are all human beings. We can make mistakes. I make a lot of mistakes in my YouTube. Sometimes I really hate my videos and I hesitate if I have to upload my video or not. Even C++ standard makes quite a lot of mistakes. For example, one prominent mistake that C++ community made is C++ 98 exception specifications. One prominent mistake that C++ community made is C++ 98 exception specification. This specification failed and is deprecated in modern C++. Also, in my previous video about unique PTR2, there is some mistake in the implementation of make unique. If you are doubt, please watch this video, then you can understand what kind of mistake C++ standard library or standard committee made when they implement make unique standard library function. There is also another mistake that I will talk in this session. If you double click this link, this is std tuple, then you can find make tuple. Okay, this implementation looks simple enough, but there is one mistake. This std make tuple made one mistake. I'm going to address that in this session. My point is, we make mistake. We all make mistake. So be tolerant about others' mistake. Also be tolerant to my mistakes. Please leave your comments. From our previous session, please download source code if you haven't downloaded yet, clicking this link. And also note that if you want to follow this session, you should have watched this video, because we will continue this session. In this session, we will implement make tuple. Where it is? We will implement std make tuple, and we will fix the flaw in this algorithm. In download folder, this is the file. Copy the folder. Then in your working folder, paste to your working folder. Double click the folder, copy folder path. On your command prompt, right click, properties, start in, click OK. Then start Visual Studio Code. Our previous folder is not open, then open. Paste the folder path like this, then select folder. Click blank space here, then click this button. 10 tuple. In this folder, click pch. Click this button once again, pch cpp. Click this button once again, tuple cpp. In pch header file, include talk play fun type util.h. Let's include one more. Include type function tutorial type liv. We implemented this file in our previous sessions. in PCH CPP file include PCH H. Then in tuple include PCH H. We will include one more file here, include CSTD IO. Then auto stream talk play fun stream auto NL stream get console out int main stream hello tuple NL Control B. Then in command prompt dir cd10 tuple. We need to first compile the precompiled header cl add to dot pch local pch cpp. We are compiling precompiled header cl at msbc underscore local tuple cpp. Okay, and you should see this message. Now we will consider this problem first. Understand the modern C++ language correctly. C++ 11 standard is completely rewritten from scratch. Do not use C++ 98 standard practice in your C++ programming. std string get string constant character message std string str msg printf the memory address of the string internal buffer %p then here str cstr, it returns internal buffer's address string pointer. Then return str. We will create one more function std vector template type name type name types type make vector type first types args. I will talk more about variadic template in some future sessions. std vector type. Please note that it does not work always. It does not always work, but it's okay for this demonstration purpose. B std forward type first std forward types args. Now we print the internal memory buffer of vector with this syntax. The memory address of the vector's internal buffer. We can say b 0 address. Memory address of the strings internal buffer. Okay, now we are testing this function, these two functions. Void test modern cpp. We are calling this function first, auto str get string a big long string literal to std string. Now we called this function. This is literal string. I explained about the literal string in our previous session. In our previous session, the most confusing concept for both C and C++ learners in this video, I explained about the problem of this literal string. They are not stored in function stack, but they are stored in data segment which cannot be modified. Then using this function, we convert into string, std string. Then we receive the returned string. Now we print out the address like this, copied, then copied like this. Now here, auto b, we are calling this function make vector. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We make vector. Then we print out the internal buffer of this vector. So we compare. This is before the function returns. This is after function returned. So we are comparing internal data structure of vector b with this b. Also with the internal memory buffer of str from string and from this string. We copy this. Like this. Then we build. Warning. Not all control path returns a value. Sorry, we have to return value. Return b. Compile once again. Okay. And see, there is something very beautiful. Strings internal buffer address D30. Here, message comes from here. This string's internal memory buffer's address is D30. Okay. And we captured the string str, the return value of str, get string. This address is the same, D30. So in this case, this string is created once, then it is passed back to str. The internal memory is the same. It means memory is allocated once here. That memory is moved to str. There is no reallocation of the memory. It is moved. The internal structure of this string is moved. Also in case of vectors, internal buffer address DE0. In this case, this memory address is DE0. DE0 and here its memory address is also DE0. So the return value of getString is moved to str, that is the memory allocated in the getString is recycled or moved to this str. Okay, the same is true here. std vector int in this case is created once in make vector, once created here in make vector function, and the internal memory buffer is recycled and moved to B. That is, std vector is created only once in make vector and recycled in this function. The result is extreme performance. That was not possible in C++ 98 standard. So C++ 11 standard was completely rewritten from scratch. Do not use C++ 98 standard practice in your C++ programming. For your comparison, scratch TCH. Okay, let's keep going. Say, if we want to achieve the same performance using C++ 98 standard, if we want to achieve similar performance using C++ 98 standard, we can do like this. Void getString std string str constant character pointer msg, then str append msg, then here std string c98 str. We have to declare first, then you can say get string c98 str c98 style programming practice to achieve performance. Okay, so we can do like this too. But it's very ugly. So in C++ 11, we can use this mechanism. We can rely on C++ 11 compiler. Now let's think about constant character pointer reference. Void constant character pointer reference using literal str t constant character pointer. Okay, then we can define string like this: literal str t str1 I love it. Okay, then we print out string str1 and L. Now let's compile it first. I copy this part, paste it here, build. Okay, we built. I love it. Please note that this is literal string. It is stored in literal. String is stored in data section. Okay, we cannot modify it. str 1 0 you while love it. We can't do this. It does not work. Let's try. No, you cannot assign variable that is constant. Okay, what about this? I modified like this. Now it's character string. Now let's try it. Wow, it works. We modified to y, but it is still, I love it. Now let's compile with GNU compiler. G++, std, C++17, Tuple, cpp, o, gexe. Sadly, it gives warning. POB is converting string constant to little t, aka character constant. Okay, now let's see if it is built. G is created. Now let's run. Crash it. This string is not displayed. When you compile, it gives warning. When you run it, it crashes it. So it's not working. I'll change it back to constant and remove like this. Then we can change str1 to some other literal string. You love me. Okay, stream str1 and L. You might think, oh, I changed it to str to new str1. Yes, you can change like this way. I will explain it. Let's build first. GNU compiler. Yes, it works. But still, you cannot modify the contents of this string. You are pointing from one. You are pointing str1 from one literal string to another literal string. You still cannot modify str1 elements. Okay, we cannot modify string str1's elements. If we want to modify it, then we have to do like this. std string real string. This is real memory buffered modifiable string, like this. Then stream real string nl real string. I can modify like this. Yes, like this. Let's build. Okay, this is real memory buffered modifiable string. This is real memory buffered modifiable string. You can modify elements like this using string, But using this literal string type, constant character type, we cannot modify. We can point, this is pointer, we can point from one string to another literal string, but still we cannot modify elements of the string. So what is constant string reference? This is like this. Constant character, this is pointer, reference, srf, str1. This works because this is reference. Instead of doing this, we can do like this. This is the same. Like this. Reference srf str1. It is reference. Still as srf, we can assign another literal string. Another literal string. Yes, it works. But we cannot modify a strf element like this. We can't. Why? From A like this. We can't do this. Now let's build once again. GNU compiler gives warning. It is not warning, it is error. 89. This gives error. In case of GNU compiler, let's see Microsoft compiler. Microsoft compiler also gives warning. What about if we modify it? We modified, then Microsoft compiler works. Now we print out stream srf nl. Microsoft compiler builds, but it does not work. We modify the first character, another literal string with A, but it returns still all the contents. With the GNU compiler, is it warning? It's warning. Okay, so it crashed. In case of GNU compiler, this works. String works, this works, but it is crashed. We cannot see this message at all. So don't get cheated with this kind of things. Now let's think about tuple. For more information about tuple, please refer to this documentation. Tuple is introduced since C++ 11. And you can have more samples here. I will explain them and I will explain how to use them. Void tuple basic. So we can create tuple like this. std tuple. We are providing element type here. For example, int double constant character pointer t1. We are providing element integer, floating point number, then constant literal string. This is so-called tuple. Then we can access each element. We can access each element of a tuple t with this syntax: std cout std get 0. This is index. This parameter is non-type template parameter index, then t1. I will just use a stream. If you want to access this, please note that this is instance of tuple. If we want to access a second element, std get 1 t2 and l stream std get 2 0 1 2 like this, t2 t1 and l. Now I copy this function, copied, pasted here. I display it. Now let's build and run here. M. This is so-called tuple. So we can access 1, the first element, the second element like this syntax, and the third element. Here is easier way, or you can just say stream t1 and l. You can also access like this. This is for special case. Like this. Let's try with GNU compiler. G++, std, C++17, tuple, cpp, o, gexe. G. So GNU compiler works. Warning comes from this here. Constant. I will disable this part to suppress warning. Okay, it works. I think I need to precompile here. Include pch h. This is to precompile pch header file. Then it builds faster. There is another syntax. Please note that this does not work. std cout t1 std and there. This does not work. This does not work. C++17 standard introduced structured binding. It is something like this. Auto reference age weight name t1. This is structured binding. We can extract each element. Stream zeroth element of t1 age and then stream 1th element of t1 weight and then stream choose element of T1. Name. We are learning basics about the tuple. G. It works the same like this. How can you get tuples element count? We can get element count like this. std tuple element size. We have to provide this tuple type like this using tuple t I copied, pasted here, then tu ple tuple t. It becomes simpler, and we can use this type too. It returns element count of the tuple. std stream tuple t's element count. See, element count is 3 because it has 3 elements. 1, 2, 3. Please note that we initialize this as literal string. We can examine this type. Stream T1's zeros element type. Do they have functions for this? How can you find out tuples element type? Type of the specified element. So we have to use this syntax. Tuple element t. It returns type. Like this. std tuple element t zeros type of tuple t and L. This, please note that this is type. Okay, so I will say like this using T1's zeros t. Tuple T1's zeros element type. So we can display type name like this. Talk, play, fun. Get type name. We have to provide the type here. Now second element using T1 first type. First second. This is first. This is once. This is 2. Then we can display element type like this. Let's see. T1's zeros element type int double constant character point. I will modify it like this. See? So we can extract element type like this. This is syntax. Zeros element of tuple t's type. This is tuple t. First element, second element. Zeros, first, second. So we can display type name of each element. Int double constant character. Int double constant character. The question is how they implemented this std get and tuple size and tuple element t, how they implemented. In case of tuple size, we already implemented these type functions. For example, stream, the count of tuple t's element. We already implemented type function tutorial, type count v, tuple t, and we already implemented this type count function. Let's try it. See, tuples element count 3, the count of tuples element 3. We already implemented this function. In type function and template parameter in this video, we already implemented. You can find this source code. This was type function tutorial 4 here. Element count, type count. See, this is the function we implemented in this episode. And we will also implement tuple element t type functions. We will implement all or most of type functions included in C++ standard, and we will also improve these type functions for our own use. For example, we can print out T1 and L like this, and T2 std make tuple. It has a few flaws. This make tuple function has a few flaws. Std make tuple has a flaw in it. We will fix these issues in future sessions. Let's build. See, this is T1, T1, T2, T2 is displayed. How did I implement it? Stream, this class. Of course, stream does not work. std cout does not work. T2 std and there, it does not work. In future sessions, we will learn all details about type function. And please watch this video too. If you watch this video, you will learn what we can do with tuple or type functions. Please leave your comments and questions. Also note that I do not make script when I make videos. These are my script of this video. I do not make script in advance. So I can't forget what I have done, and if I forgot it, for example, I make promise to you through videos. If I don't deal that topics in future sessions, then please remind me leaving comments. Thank you for watching.